Hi dear students, today we again come with a new video of class 10. In the previous video, we have discussed about calorimetry part 1 and today our target is to discuss about calorimetry part 2. Okay, so what things we are going to discuss here? So in this part, mainly we are discussing about change of state or phase and latent heat. So these two things we have to learn in this chapter. To tell the truth, this chapter, this portion especially, it is very easy. If you just go with me, what I'm doing here, if you follow me, then I think it should be the easiest chapter. Okay, let's see. So first we have to learn about change of state, and no need to tell to you, it is very much easier that you have already learned earlier. Okay, so you are very much familiar with the change of state. What is it? A change of state means that there are mainly three states are there: solid, liquid, and gas. So we know, due to the absorption or reduction of heat energy at a constant temperature, when one state is transformed into another state, that is known as change of state. And if I have shown you that it is also, I'm telling one thing, that whatever the things I am showing you here, you know it very well. Earlier you have learned it in junior classes: solid, liquid, and gas. These three states are there. If you have given heat energy, solid has converted into liquid, and this process is known as melting, that we all know that it is a melting. Similarly, if you heat liquid, then it will be converted into gas, and that process is known as boiling, or sometimes it is known as vaporization. Same thing is there. Later, if you extract heat from gas, then gas is converted into liquid. That process is known as condensation. And when you again take heat energy from liquid, this process is known as freezing. Sometimes some solids have shown that if you heat the solid, it is directly converted into gas, and that process is sublimation. And if you take heat energy from the gas, for that type of material, it is coming to solid again, and it is known as solidification. So this is the whole story of change of state. Okay, and not, I'm telling you earlier also that you are very much familiar with it. Then what new thing we have to learn here, especially to tell everything, what is the process, how it has done? This is not my intention, because you have learned. I'm just focusing on the new thing. Okay, so let's see. So first we'll start from melting. So melting, we all know what is melting. So melting is a process when at constant temperature a solid is converted into liquid by absorption of heat energy. That is known as melting. Okay, so two things I have mentioned: one, at constant temperature, and number two, absorption of heat. Now you might be thinking that if we are absorbing heat energy, so how the temperature should be constant? That is a thing what we have heard from the very earlier classes. We will get the idea why the temperature is not increased, but that will come little later. What is melting? I have already told, at constant temperature when A solid is directly converted into liquid by absorbing heat energy. Or in reverse way, whenever we have to define freezing, freezing is the opposite thing of melting. So if I am talking about freezing, then the same thing will happen, that at constant temperature, when a liquid is converted to solid by extracting heat energy or liberating heat energy from it, that process is known as freezing. And the constant temperature is known as melting point. And for freezing, it is freezing point. And it is told that for a pure substance, if I am talking about a pure substance, for pure substance, melting point is equal to freezing point. Okay, and if I have given the example, I know you are very much familiar with it, that at 0 degree centigrade, if I am talking about ice, so its melting point is 0 degree centigrade for the case of ice, and freezing point of water, that is also 0 degree centigrade. Okay, so for a pure substance, melting point is and freezing point will be equal. And example, as we have given, we know that at 0 degree centigrade, ice is converted into liquid by absorbing heat energy. So this thing is very much easier that you have learned. Now what do we want to show you, that if I want to represent one graph by seeing the change of state, that is specially melting. That means if I represent melting through graph, how we can able to show it. So let's see, and it is new for you. So representation of melting by graph. Representation of melting by graph. So how can we able to represent it? So here we have to take an example. So we are taking the example of ice. So ice, it is there in 0 degree centigrade. You are giving heat energy to it, and after some time it is converted into water at 0 degree centigrade. And then if you have given heat energy, so this triangle means you have given heat energy. This triangle represents heat. So if you have given heat again to 0 degree centigrade of water, it is converted, assume 30 degree centigrade of water. So if you want to show it graphically, how we have to show? So for that reason, so it is very clear, to show a graph we need two axes. This is x and this is y. Along y-axis we are taking temperature. On y-axis we are taking temperature in degree centigrade, and along x-axis we are taking time in second. Now I am giving the scale. Okay, so let's see what are the scales we have to take. So assume it is 0, 40, then 80, then 120, then this much of second actually, then 160, then 200, and then 240. And temperature, assume here 10, 20, 30. Okay, so whenever you have taken, assume you have taken ice. Okay, assume this is an ice cube you have taken in a beaker, and then you have put it inside a hot water, and you have put one thermometer in it. So otherwise how you can able to measure the temperature? And this water, it is heated by a burner. Very easy thing. Okay, that is the setup. Because if we directly heat the beaker, there will be a chance that it is made by glass now, so it can be broken. So whenever ice is at 0 degree centigrade, if you have given heat energy, so water is converted, 0 degree centigrade ice is converted into 0 degree centigrade of water. See, the temperature is not increased. So if I am starting from here, so assume up to 2 minutes, that is 120 seconds, the water, it is ice and it is converted to water. So in this place, it is a combination of ice plus water, and in this place, the melting is occur in this portion, because you see here the temperature is not changed. Okay, as you have given heat energy, only the change of state is occur. Temperature is remain same, 0 degree centigrade ice to 0 degree centigrade water. And if you have given more heat energy, then it starts increasing, and it increasing up to 30 degree. So at 200 seconds, the temperature is at 30 degree centigrade. So it is the 30 degree centigrade of water. So if I just show you by some line segment OAB, so this OA, it represents melting, and AB represents rise of temperature. Okay, so by that graphical representation, we have shown you how the temperature is increased by the heat energy is given to it, as well as the state is changed. Here ice to water, state changes occur. I have written ice plus water means in this time ice is converting into water, but the temperature remains same, and in this point whole water is whole ice is converted into water, and then the rise of temperature is occurred. Okay, I think it is clear for you. Now the next thing we will see here, that what will happen that if a substance melts, how its volume is changed. Okay, that thing also you have read it in class 8. Okay, if you follow your book properly, this thing is there in your class 8 book, that change in volume due to melting. See, in this case, when we are discuss about the volume, here we have to see there are two kinds of substances are there. One kind of substances like lead, wax, this type of substances are there which expand due to melting. Means if you melt these substances, lead or wax, they expand due to melting. Okay, and some kind of solids are there like ice, these substances are contract due to melting. So we have seen the two type of things. So for some solids the volume expand, and for some type of solids the volume contract. Okay, now next thing we have to see the effect of pressure on melting point. Effect of pressure on melting point. Now you might be asking me, sir, why you have written it together? Because this effect of pressure on melting point is related with the volume. How? Now we have seen some objects are there, some solids are there which expand due to melting, and some solids are there which contract due to melting. Whenever we are talking about pressure, here also 2 points will come. Number one, the substances, listen to me very carefully, the substances which are contract their melting point decreases with increase of pressure. What I have told you. Now, as we have seen, the some substances are contract. Here it is told the substances which are contract, their melting contract. I have mentioned due to melting, contract due to melting. Their melting point decreases with the increase of pressure. If you increase pressure on them, their melting point will decrease. Now you might be asking that why? The reason here, it is little bit of higher thing. So here I'm not discussing the reason. You have to remember this thing, that it is occur. I can show you example, but why this thing is occurred, for that many more things are related with it. So here you see, for the case of ice, if you increase pressure on it, then its melting point goes decreased. That means we know the melting point of ice is 0 degree. If you increase pressure, then it is decreased by how much, you know? It is decreased by almost minus 0.0072 degrees centigrade. Okay, so it is decreased. If you this much decreased per atmospheric pressure. So if you increase more pressure, it will decrease more. Okay, so here we have to see that if you increase pressure on ice, then its melting point will be decreased because its volume decreases or it contracts due to melting. Similarly, if I have gone for the second part, that the substances which expand due to melting, their melting point increases with increase of pressure. Many things is written here. What? So in the previous case, as it is decreased due to the increase of pressure, the melting point. In the next part, we have seen the substances like lead, wax, which are expand due to melting, their melting point increases with the increase of pressure. Okay, with the increase of pressure. So these things you have already learned in class 8. I am repeating these things so that you cannot forget it, because from here the question may come. And now if I am talking about the example or the experiment, that as the pressure is increased, how the melting point is decreased for water, because it is easier to show. Because lead and wax, it is difficult to show how the volume is increased or how the melting point is increased. But water we can show you, that if you take two ice cube and if you apply pressure on them, you will see that after some time the two ice cube is just connected with each other and make one ice cube. Okay, if you try it at your home, you will get it. two ice cube you will take and apply pressure on them. Okay, what will happen in that case? Now whenever you have taken two ice cube and you are applying pressure, then the pressure is applying in this point. Okay, so as the pressure is applied in this point, so what will happen? Melting point decreases. As per increase of pressure, the melting point will decrease. So melting point decrease below 0 degrees centigrade. Okay, because generally the melting point is 0 degrees centigrade and ice is at 0 degrees centigrade. Whenever you are applying pressure, the melting point goes below 0 degrees centigrade. And that time the temperature of ice cubes are 0 degrees centigrade. And for that case, in this joining portion, the ice melts. Ice melts at 0 degrees centigrade. Why? Because due to the pressure, melting point decreases below 0 degrees centigrade. So ice is already at 0. So at that temperature, the ice in this portion, they melts. So melts means they convert into water. So they connect to each other. And when you release the pressure, okay, so due to the release of pressure, again the melting point goes to 0 degrees centigrade and again it solidify. And as it solidify again, so it will be a continuous bar of ice. So by applying pressure, you can make the ice more longer. Okay, because they are connected with each other with the application of pressure. That is experimentally shown by a scientist, that is Bottomley. The name of the scientist is Bottomley, and the experiment is shown by him. It is Bottomley's experiment. As it is not in your syllabus, so I am not showing you that experiment or not telling you the experiment, because if we tell here it will take huge time. Okay, rather we are going forward. If I get time, then I will explain how Bottomley shows that due to the application of pressure, the melting point of ice decreases and how it decreases. Okay, so I think it is clear. Next, and you can say the last part of melting here, that is effect of impurities. Effect of impurities on melting point. Impurities means if you add some extra thing on with the solid, then how its melting point is changed. It is told that if you add impurities, then melting point decreases. If you add if you add impurities with the solid, then its melting point decreases. It is told that if you add adequate amount of salt with ice, then the melting point of this mixture is going to minus 22 degrees centigrade, almost minus 22 degrees centigrade, because you know for the case of ice it is 0 degrees centigrade, but as you add salt as impurities, then it is going to minus 22 degrees centigrade. So definitely the mixture should be adequate, and that's why you will show it, and this is known as freezing mixture. Okay, so many places, just like fish shop, there you know that there we just want to keep fish for a long time. The fishermen, they have taken fish from the sea or river, and it is taking a long time to reach. So that time the fish is kept inside the freezing mixture, so the temperature is well below, and so that the fish remain proper. It is not rotten there. Okay, here this freezing mixture is also used to make kulfis. Okay, kulfis we all know, there also this freezing mixture is used. Okay, so these are the effect of impurities on melting point. Now we'll go for boiling or vaporization. So now we will discuss about boiling or vaporization. Simple thing, that definition also we know, that it is a process when the liquid is converted into gas due to the application of heat energy at constant temperature. That process is known as boiling or vaporization. Okay, and the constant temperature is known as boiling point, that also you know, or vaporization point. Or in reverse order, when you have taken heat energy from gas at a constant temperature, that time it is converted into liquid, and that is known as condensation, and that point is condensing point. That constant temperature, that is condensing point. And here also for pure substance, boiling point and condensing point, it is equal. We know for the case of water that at 100 degrees centigrade it is the boiling point of water, and similarly at 100 degrees centigrade it is the condensing point of steam, that is the gaseous form of water. So for pure substance, the boiling point and condensing point remain same. So these parts are very much easier, and you know that 100 degrees centigrade the water is converted into gas, that is in a form of steam or vapor. Now we will discuss how the volume is changed due to boiling. Okay, so here we have to see, just like the previous part, how the boiling point change with how the volume is changed due to boiling. So change of volume due to boiling. Very simple thing. Change of volume due to boiling. So here in the case of melting we have seen two parts, but here there is no two part. Almost all liquids expand due to boiling. Okay, so when you have given heat energy to it, so liquid is converted into gas, so definitely the volume is increased, and that's why if I write the effect of pressure on boiling point, so if we have seen there, so for the previous case in melting we have seen that due to the application of pressure the melting point can change into different substances in two different ways, but here it is only one thing. So that's why if you increase pressure, the boiling point increases with increase of pressure. Example, so very common example is there. Guess what the things I am drawing here. I don't know whether you understood or not. It is a pressure cooker. We know whenever we want to boil our food properly and faster, that time we use pressure cooker. So how it works? So especially we have given water inside it and the vegetables or whatever the substance we want to give inside. It may be chicken, it may be mutton. So after giving, we just put it over the fire. Then what will happen? This water is just converted into vapor, but it cannot able to comes out. So the pressure is increased. So as the pressure is increased, the boiling point is also increased. We know for water, the boiling point is 100 degrees centigrade. That means in 100 degrees centigrade, the water starts converting into vapor. But as it is fixed there, the boiling point starts increasing. So it is told as it is increased almost 120 degrees centigrade to 125 degrees centigrade. The boiling point increases to 120 to 125 degrees centigrade. Then if it increases, what happens? If it increases, then what benefit we will get? The benefit is as the temperature increases, then definitely uh, as the boiling point is increased there, so the food items, the vegetables, whatever the substance is there, it is boiled with a very high temperature, so that it is boiled very faster. Not only that, if you are going to any high altitude areas, we all know, we have read it in class 9, as we have gone in high altitude areas, there the pressure is decreased. So simple thing, as the boiling point increases with increase of pressure, it decreases with the decrease of pressure. You know, in high altitude, in high altitude, the water starts boiling around 90 degrees centigrade. So what will happen, you know, if you want to cook anything, if you want to boil anything, if the surface of the water is open, if you heat it, so at 90 degrees centigrade, the water starts into vapor, converts into vapor, and your food items, whatever you have given, it is not boiled. So it takes huge time to boil, and for that reason there the pressure cooker or steamed food is very popular, because if you do it inside the pressure cooker, the boiling point reaches to 120 degree to 125 degrees centigrade, and that's why you can easily cook it very faster. Okay, and that's why if you gone to the high altitude areas, the food items they are very common, that is momo and whatever their boiled food mainly, that is been taken very popular in that areas, because they cannot able to fry. If they fry, the temperature will be very less, rather they want to boil it. Okay, so that is the effect of boiling point, the effect of pressure on boiling point. Now we'll go to the next part, that is effect of impurities. Effect of impurities on boiling point. So if you add impurities, what will happen, you know? The boiling point increases. If you add impurities, the boiling point increases due to the addition of impurities. So that's why you have seen that sometimes it is happened when you have cooked, or the whatever the cook has come, when he cooks or she cooks a food of a large number of people, then he should apply salt on water. So if you apply salt to water, then its boiling point is increased, and so that the food item is boiled very faster. Okay, so adding impurities, the boiling point increases. For melting point, it is decreases, but boiling point increases with the addition of impurities. And now the last item from boiling point, that if I want to represent it graphically. Okay, assume water is given to you at 20 degrees centigrade. So 20 degrees centigrade of water, you have to convert it at 100 degrees centigrade of vapor. Okay, so if you want to show the graph exactly like same, here it is time, here it is temperature. So temperature is in degree centigrade, time that is in second. Okay, and here if we write the timing, so assume it is 40, 80, 120, 160, 200, 240, 280, 320. So this much of second, and here we are taking, assume 20, 40, 60, 80, 100. Okay, and here it is 0. And now what water is given to you, that is 20 degrees centigrade. So as you increase the temperature, so it is increased from 20 degrees centigrade and it reaches to 100 degrees centigrade. Okay, so assume it reaches to 100 degrees centigrade at 200 seconds. And now if you increase more temperature, the water starts converting into vapor. Okay, so here this portion, it is water, and here in this portion the boiling is occurred. Now you might be asking, sir, then what it is, why it is a straight line? The straight line is because we know as the state change is occurred, the temperature will not change. So if I give a name A, B, C, so AB, that gives us rise in temperature, and this BC portion, that is change in state. That means in BC portion what is there? Now it is along with water, vapor is there. Okay, so water and vapor both are staying at the same point. Okay, because the state changes occur. So that is the representation of boiling with time. Okay, that is graphical representation.